Expected value, example 4. Katie pays $10 to play the following game of chance. There's a bag containing 12 balls. 5 are red, 3 are green, and the rest are yellow. Katie is allowed to draw one ball from the bag. If Katie draws a red ball, she will win $14, and if she draws a yellow ball, she will win $12. What is the expected value of one game? What is the expected value of 100 games? So let's look at part A. We're looking at the outcomes for this event. So the outcomes that are possible: Katie could draw a red ball, she could draw a yellow, or she could draw a green. So those are her outcomes. Then we need to determine the probability for each event. So if we look at the red, her probability for that, so there are 12 balls and we know 5 are red. So the probability for pulling a red out would be 5 out of 12. For the yellow, that probability, let's see how many yellow there were. Oh, this says the rest are yellow. Let me go ahead and do the green then. The green, there are 3. So that would give me 3 out of 12. So then to get the yellow, we would take our total of 12 and subtract the other 2. The red, which was 5, and the green, which was 3. So that would give us 4. So the yellow would be 4 out of 12. So now we're going to look at creating an expected value table. I'm going to create mine kind of over here to the side so I can write a little bigger. So we would have our outcome value. And then our probability. We have 3 of those. So red, yellow, green. I'm going to come back in and fill in the values in just a minute. So I'm going to go ahead and put in my probabilities. 5 over 12 for red, 4 over 12 for yellow, and 3 out of 12 for green. So for these, our values are going to be a little different than the other problems we looked at in some of our examples. Because remember, our value is how much you're actually going to get. Okay. Now, she had to pay $10. Now, while if she draws a red ball, she'll win 14, her actual profit, or what she actually wins, would only be $4. Because we have to take how much it cost us from what we win. Okay. For the yellow, if she draws a yellow, she'll win $12. So then we would do 12 minus 10. So her value for yellow would actually only be $2. Now if she draws a green, she doesn't win anything. She just loses everything she paid. So she had to pay $10. So that green would be a negative 10. So these would be our values for each of these. So be careful when you're paying that you take whatever you had to pay out of your winnings. Looking at part D for the expected value of one game. So we're going to find that using our expected value like we do with our other problems. Our expected value would be our value for our first event, 4, times that probability, 5 over 12, plus our second event, 2 times 4 over 12, plus our last event, so plus a negative 10 times 3 over 12. Putting all of that into your calculator, you should get negative 1/6. Since we are looking at money, we're going to turn that into a decimal. So negative 0.166666, and it keeps repeating. Since we are talking about money, that's going to be negative. And rounding that would be 17 cents. So in this case, this would definitely not be a good game because in the long run, you're going to be losing money. Okay? For our expected value, make sure you don't multiply this number by 100. You need to multiply the non-rounded number. Okay, so if we're looking at the 100 expected value, so we would say negative 1/6, that's for one event, times 100. Which would give us 16.66666, and again that repeats and is a negative, so negative $16.67 for 100 games. Okay. So if you played this game 100 times, you're going to be looking at losing about $16, $16.67. So definitely not a game you would want to be playing.